All right, thanks. Yeah, my name is Ted Spears. I work for Microsemi's Programmable Business Unit. We do the FPGAs for Microsemi. My role there is to define our FPGA roadmap, so in product planning. If people aren't familiar with our FPGAs, we're known clearly for low power, reliability, and security. Our involvement with RISC-V, I think, kind of got in fairly early, and I am on the RISC-V Foundation Board of Directors, so I'm actually here not just representing the Microsemi hat, but also the RISC-V Foundation. The reasons that caught our attention early on were opportunities for innovation around the processor in the areas of low power, security, and reliability. I just felt the openness of the architecture would enable a kind of a future roadmap where we can really focus on those and innovate in those differentiating areas. At the time, we also, competitors, Intel and Xilinx have their own soft processor called Neos in one case and Microblaze in the other. And we didn't have one at the time. So it looked like the time was right, and had a customer who needed a RISC-V or needed a processor IP, and RISC-V was there, and we actually worked with Sci-Fi actually, and now sell a version of the Sci-Fi processor as our own. Won a design with that processor, and actually just took a first multi-million-dollar order for it this month, as it turns out. We also support other people making RISC-V cores, and in fact, we've shipped hundreds of thousands of units today using RISC-V. Other companies' RISC-V implementations, IP companies, to be exact, implementations of RISC-V in our products. And so we're happy we have something called the My5 ecosystem. We got RTOS, people who make tools, people who make solutions, and people who make IP are free to join our My5 ecosystem. And we're happy to promote anything related to RISC-V through our ecosystem.
My name is Naveed Shavani. I'm the president and CEO of Sci-Fi. A quick introduction to Sci-Fi was started by the original three inventors of RISC-V from Berkeley. And subsequently, we have acquired most of the team from Berkeley, and then the team from Stanford, and the team from MIT. So we have 40 PhD students and other students who were actually working on it since 2010. It's a fun group to work with. Our focus really is two things. First of all, make sure that we have a very good roadmap of RISC-V IP for our customers. So we are talking to 30, 40 top customers in the world and basically building a roadmap. We'll share that with you guys very soon on our website and otherwise. And the second thing we are doing is that we are building a chip design platform which will use these cores and many other things, which will enable two things. Number one, it will dramatically reduce the cost of prototyping. So let's say if the current cost of prototyping is 1 million for one platform or 7 million for another platform, we will get it down to 100K or 750K. So that is our publicly stated goal. Why? Unless we can dramatically reduce the cost of prototyping, hardware innovation is not going to happen. Period. The big difference between hardware and software is the prototyping cost in software is extremely low. And how does that happen? Because they have a software stack. They use 95% of the open stack, and then they only build 5% on top. And very crucial part of this prototyping reduction of cost is a program called Design Share. And we are very happy to have people like Mahesh from Analog Bits, Jeff from Press Logic, I think Camille is here. Many of our friends, all are here. Farzad is here. So all of you guys are participating in a design share program, which basically says, how can we get this IP to people who are trying to rapidly prototype, based on some existing templates, extremely low cost. Once they are successful, and we know in ASIC business, only 1 out of 10 are going to be successful, then they have the ability to raise money and they can pay us. We think that kind of prototype system should be on the cloud. It should be available worldwide, and it should be so easy to use that I keep on mentioning 2 guys in Brazil in a garage should be able to get to silicon, which is completely impossible today. And I think unless that happens, innovation moves out of Silicon Valley, out of India and China. I mean, right now, innovation is stuck in a few places in the world. It needs to happen everywhere in the world. So we have made a public commitment that all our software and all our things will be available to all universities worldwide for free. And we will start with the 50 of the poorest developing countries in the world, and we'll make our software free there as well. So the whole idea really is to get the innovation going, and I think RISC-V is the best excuse that hardware has ever invented to get that going, and use that to promote the open source hardware platform as well as the innovation. And I think we are very committed at Sci-Fi to make that happen.
Good morning. My name is Emerson Shao. So I'm the head of Ennis operation in U.S. So Ennis is a CPU IP company, so the only focus is CPU IPs. So we were funded in 2005. So back in 2005, I remember we still have a lot of standalone CPU IP companies like MIPS, ARC, and Tensilica. There was this question that why we need another CPU company. But we saw a need that the consumer electronics or consumer ASICs required to have more computing power and also be able to last a longer period of time. Our focus is really on the high-efficiency microcontroller IPs. And it was a great success, so we went IPO in 2017. And up to date, we have about 150 customers worldwide. And the stories begin in 2016. I was talking to Rick O'Connor regarding joint force with RISC-V. And then it was interesting, open source hardware, like Naveed said, this is open innovation, right? And then immediately we decide, yeah, this is it. So because, we've been hearing from customers, we're tired of being tied to one company, one ecosystem. We want to have open ecosystem. We want to have open innovation, right? So we jumped on the trend in 2016 as the founding member, and then we released our first two RISC-V core in 2017. We're expecting a few tape-outs this year on a RISC-V product. We also plan to release a few new RISC product line this year, and it's going to be, I think it's going to be exciting years for Ennis. Thanks.
Thanks, Emerson. I'm Art Swift of Esperanto Technologies. I see a lot of familiar faces around the room. I'm standing in for Dave Ditzel, who I think you all know is one of the most famous computer scientists of our generation, who co-authored with Dave Patterson, the professor at Berkeley, The Case for RISC, which was the original technical paper which spawned the whole RISC revolution in 1980. Dave's sick today, so I apologize that I'm standing in. My own legacy goes just as far back. My first CPU-related job was working on chips that went into the Cray computers. So Cray Research was my first customer, and along the way, I was one of ARM's biggest customers. I was VP of Marketing for DEC Alpha, VP of Marketing for Spark, VP of Marketing for MIPS, CEO of Transmeta, consultant for Paul Otellini at Intel, and now VP of Marketing at Esperanto. I'm also vice chair of the marketing group of the RISC-V Foundation. I think I can bring a little perspective on RISC-V to all of you. And I can tell you honestly what decided Esperanto in favor of RISC-V as we develop our high-end AI chips was that we had the opportunity to innovate on the RISC-V instruction set. We could extend it, we could participate in the open working groups, we could be a contributor to the community. And so we saw it as a really great opportunity. It is the platform for innovation for the next 10 or 20 years. Now, that's sad to say that the other players really haven't provided that same opportunity for innovation. If we wanted to innovate on an ARM platform and take a multi-use license, it would have cost us millions and millions and millions of dollars. We certainly couldn't do it on an x86 platform. And then you might imagine, with Dave Ditzel's history in instruction set architectures, we considered developing our own. But when we studied RISC-V, we also found it was very efficient, could generate very small cores, and could be very power efficient while delivering high performance. So we decided there's no reason to create our own ISA. This is a great one, so we embraced it. Anyway, look forward to working with all of you in the future.
Series of questions, and actually, if we have some time, I'll walk maybe the microphone, get some of your questions as well, so actually get some interactive nature of this audience. But I think I've got a few questions to get started here, and I guess my first question is, if you could pull one factor for RISC-V, what was the most compelling aspect of RISC-V? Was it the free, the extensible, the low power, the small size, or just the fact you can innovate on an open platform?
Well, when I got engaged with RISC-V, I thought the innovation part and the free